Good morning, good afternoon, and good evening. In this presentation, I'm going to discuss about blockchain as a service architecture for DApps and application for veterinary medicine case study in Ireland. Blockchain technology eliminates centralized trust and provides solutions to problems when trust between participants is a significant concern. So blockchain transactions are immutable and transparent, as you all know. Trust and transparency are important aspects for most of the applications, including veterinary medicine prescriptions management. So vet treatments for food processing animals need transparency and trusted data management to reduce health risk and maintain sustainable farming. So some of the selected challenges in veterinary medicine prescription management include overuse of prescriptions, the use of counterfeit drugs, monitor constraints, and lack of consumer access to information. Methodology. Initially, we did a detailed study based on the literature available on the internet regarding veterinary medicine prescription management and the challenges faced in Ireland, the primary actors, secondary actors, the constraints, etc. And then we investigated methods for maintaining trust, transparency, accountability, reliable access to trusted information, and then loosely coupled architecture and distributed immutable data storage technology. We selected Ethereum and IPFS, and then started prototyping and testing for trusted provision, provenance, traceability, and cost. We did a detailed study and identified use cases and developed a veterinary medicine prescription management case study in Ireland. We identified main actors as farmer, regulator, and the user. Secondary actors as a veterinary practitioner, pharmacy, registered retailer, and licensed merchant. So the farmers basically can buy various types of medicine from various secondary actors, and farmers can request request for an examination from a veterinary practitioner. Then the veterinary practitioner can perform an inspection and prescribe a prescription. So when the prescription is prescribed, so all the prescribed medicines are implicitly verified with Health Record Products Regulatory Authority. And again, the veterinary practitioner should be a registered practitioner to prescribe medicine and create prescriptions within our system. And when a practitioner is creating a prescription, it is recorded on the blockchain. Then, as I said earlier, all the prescribed medicine are implicitly verified with the records in the Health Products Regulatory Authority, and then it is blocking the use of unregulated drugs within the farming community. And again, the farmers can purchase medicine from practitioners, pharmacy, registered retailer, licensed merchant. All these secondary actors can view the prescription, and they can issue prescribed medicine, and also when they issue other drugs, unprescribed medicine, and they can record them with the prescription as well. We have that facility within the prescription. So all these records are recorded on the blockchain. So at any point, the farmer can see his latest prescription, all the medicine he has purchased from all these actors. And then farmer and practitioner can perform treatments, and all these treatments are recorded on the blockchain as well. When they are performing treatments, then withdrawal period constraints can be set up automatically. What are these withdrawal period constraints? For example, never sell animals or supply milk before the withdrawal period has elapsed, something like that. So then the regulators can log into the blockchain at any point using their wallets and check all these transactions, and again the users can view the blockchain, the transactions regarding veterinary medicine prescriptions management, whatever the necessary transactions. So maybe user may be interested in knowing what kind of medicine we used for that particular livestock when he's buying a packet of meat from the shop. And that is about the use case. This is the solution architecture we have proposed in our study. The participants, patient, licensed merchant, pharmacy, regulator, doctor, all these people can log into the blockchain and perform their activities, and all the services are provided as blockchain as service from the blockchain as service API, identity as service, regulator as a service, pharma as a service, etc. And the blockchain as service for DApps. So our blockchain as service is connected with IPFS through an API. So the API is used to talk to IPFS, smart contracts, and blockchain state and events. So when user is making a request, so it will invoke the blockchain as service, implicitly called the API services to talk to the smart contract, blockchain, and IPFS. Here's a simple illustration of create and view prescriptions. The farmer is when farmer is creating a prescription, farmer requests an inspection from the vet. Then the vet does farm inspection and create a prescription using vet as a service, and save the prescription on IPFS, get the hash, save the hash on the blockchain. And for the farmer, and again he can view the prescription, find the prescription hash from the blockchain, get the hash, find the information using that hash on IPFS. Or farmer and the vet has a wallet-based access control so to the blockchain. So when they can use their username passwords to log into the wallet, then they can access the blockchain services. And here's the illustration of the smart contract, a part of the smart contract and some functionalities. So here vet registration details in a map. This is a state variable. This is again a state variable. This is an event. This is again an event. So here you can see map for veterinary vet details and map for prescription details. So you can, for example, you can have the pharma ID and the latest prescription. When a prescription is created, all this information is recorded on the events on blockchain, and the prescription details are on IPFS. The hash is recorded on the blockchain as an event. So using pharma ID hash, so from this hash you can see this is the IP gateway to IPFS. Using the hash you can view all this information. If you don't have the hash, you cannot view this information. And we did kind of a cost comparison to see, because when we develop distributed applications, decentralized applications, cost is a main concern. So you have to be careful when developing smart contracts. Two important things. One is security of the smart contracts and the cost of the smart contract. You should not use unnecessary variables, unnecessary state variables. You have to properly manage events. And here you can see event cost. The execution and the transaction cost are less for an event, but when you use map, the state variables, these costs are you need a higher cost. Transaction cost includes the cost for sending data to the blockchain and the execution cost. The execution cost is the cost of computational operations on the Ethereum virtual machine. And the conclusion, this paper presents decentralized blockchain as service solution for veterinary medicine prescriptions management. Smart contracts manage prescriptions. All the purchases will be verified and recorded on the blockchain and IPFS. The record keeping is completely decentralized, immutable, and transparent. Therefore, there is no possibility for overuse of prescription medications. Blockchain and smart contract-based verification of drugs can stop using counterfeit drugs. The provenance and authenticity of drugs are verified every time they are prescribed and dispensed. The transparency, immutability, and reliable provision to transactions enable monitoring constraints. The smart contract-based verifications can monitor control measures. And reliable provision to immutable and transparent transactions enable developing traceability solutions for customers. In the future, when you buy a packet of meat from the shop, you can see how these livestock were maintained, what kind of medicine were used at livestock. Thank you.